Hi students, welcome to this video session. My name is Samuel Chukwuemeka. In this video session we shall solve equations with rational numbers. Equations with rational numbers. This is a continuation of the video of the video on rational numbers that we did in the previous lesson. So we are going to look at doing two things. We're going to look at doing at least three things in this video. The first thing we want to do is we solve equations with rational numbers by clearing the fractions. The second thing we want to do is we solve equations with rational numbers by clearing the decimals. And then the third thing we want to do is to solve real-world problems involving equations with rational numbers. Okay, now this is based on the Alabama Course of Study standards. Okay, so now let's start. If we want to solve equations with rational numbers, by clearing fractions. The first thing we want to do by clearing fractions, number one, the first thing we want to do is we want to find the least common denominator of the fractions. Okay? Find the LCD. Okay. Now it is highly recommended that you've done all the previous lessons before this lesson. Okay. Now this means least common denominator of the fractions. That is the first thing we want to do. Then after we get the least common denominator of the fractions, we want to use that least common denominator to multiply both sides of the equation. Okay, you can say multiplying both sides, or you can say multiplying all terms. It's the same thing. You want to use the least common denominator to multiply both sides of the equation. Both sides, or you can say all terms of the equation. So once you do that, you now have an equation that involves only integers. Okay? So you now have an equation that involves only integers, no fractions anymore. And then once you now have that, you can now solve the equation. The next thing, you now solve and check the equation. Solve the equation. And next one, check your solution. Okay? So these are the steps. If you want to solve equations with rational numbers by clearing the fractions, these are the steps that we shall follow, and we shall get it right. Let's see. Okay, number one. We have 1 over 2 times j plus 7 over 10 equal to 4 over 5. Let me use this space for LCD to find our LCD. We've talked about that before. Now, the denominators are what? 2, 10, and 5 are the denominators of the fractions. Okay, now these are the fractions on the left-hand side and on the right-hand side. The denominators are 2, 10, and 5. So we want to find the LCD of 2, 10, and 5. 2 is a prime number, so it's 2. Excuse me. 10, if we find the prime factorization of 10, it is 2 times 5. And then 5 is a prime number. So 5 appeared twice, so we're going to use it one time. So the LCD will be 2 times 2 times 2 times 5. Since 5 appeared twice, use it one time. So this will be 2 times 2 is what? 4. 4 times 5 is what? 20. So the LCD is 20. So what we have to do now is we use the LCD to multiply both sides of the equation. So this will be 20 times 1/2. Now, 20 times the left-hand side. Okay? 1 over 2j plus 10 over, plus 1 over 2 times j plus 7 over 10 equal to 20 times 4 over 5. Now, you can apply the distributive property here. Okay? And that is a step you might want to put in those steps I put. You might want to put the steps. You now apply the distributive property here. If you're using 20 to multiply both sides, then you have to apply the distributive property. Otherwise, if you're using 20 to multiply all terms, then that means you have already applied the distributive property. Okay? We shall look at that in the second question, to multiply all terms. So here, if we use the distributive property, using the distributive property, on the left-hand side, we now have 20 times 1 over 2j times j plus 20 times 7 over 10 equal to 20 times 4 over 5. So let's now divide. 2 will divide 2 to give you 1. 2 will divide 20 to give you 10. 10 times j is 10j. Right? Plus 10 will divide 10 to give you 1. 10 will divide 20 to give you 2. 2 times 7 is 14. Okay? Equal to 5 will divide 5 to give you 1. 5 will divide 20 to give you 4. 4 times 4 is 16. So we now have this. 10j plus 14 is equal to 16. This is now an equation that involves integers. So, in essence, when we are given an equation with rational numbers, okay, that involves fraction, in essence, what we want to do first is to convert it to an equation that involves only integers. That is what we want to do first. Okay? So, when we now solve this equation, let's solve it and then we check it. We have 10j plus 14 equal to 16. So, as usual, what some teachers will do here is to just subtract 14 from both sides. And what you now have is that 10j is equal to 16 minus 14 is what? 2. And then you can now divide both sides by 10. You can now divide both sides by 10 to isolate j. 10 divided 10 is 1, so j will be 2 divided 2 is, if you simplify this fraction, 2 divided 2 is 1, and 2 divided 10 is 5. So j will be 1 over 5, if you simplify the fraction. Okay. The next thing we want to do is to do what? To check our work. So let's go ahead and check it. So first thing we want to write is we write check. Okay? And we write the main equation as usual. 7 over 10 equal to 4 over 5. So our left-hand side, we write our left-hand side and then our right-hand side. Our left-hand side is what? 1 over 2 times j plus 7 over 10. And our right hand side is what? 4 over 5. So we now substitute. We now substitute 1 over 5 for j on our left hand side. So this is 1 over 2 times 1 over 5 plus 7 over 10. When you do the order of operations, okay, first of all you multiply. This will give you 1 over 10 plus 7 over 10. 1 over 10 plus 7 over 10 will give you what? 8 over 10. And when you simplify 8, because these are like fractions, 1 plus 7 is 8 over 10. When you simplify 8 over 10, divide the numerator and the denominator by 2, you now have what? 4 over 5. You have 4 over 5 on the left hand side, you have 4 over 5 on the right hand side. We got it? Okay. The next one is question 2. When we come to question 2, we have 3 over 10 minus 7k over 15 equal to 2 over 3. So what we want to do here is we want to, first of all, the first step, find the LCD of 10, 15, and 3. So let's do that. LCD of 10, 15, and 3. The prime factorization of 10 is 2 times 5. The prime factorization of 15 is 3 times 5. And then 3 is already a prime number, so you can't find the prime factorization. It's 3. So 3 occurred twice, we will count it 1 time. 5 occurred twice, we will count it 1 time. So the LCD will be 2 times 3, 1 time, 3, times 5, 1 time. So the LCD will be 2 times 3 is 6, and 6 times 5 is 30. LCD is 30. So the next thing we want to do here is we use 30 to multiply all the terms. Okay? You can, if you say, now, let's get this right. If you say use 30 to multiply both sides, then after that you will have the distributive property. You will use the distributive property. Another thing you can do is to say use 30 to multiply every term in the equation. That means you have already used the distributive property. Okay? Now if we do that, use 30 to multiply every single term in the equation. This will be 30 times 3 over 10. This is really, if you really want to skip some steps, yeah, if you don't want to say distributive property. Now, but I advise you, I mean, it doesn't matter, but you can use the first one we did using the distributive property. Okay? So this will be 30 times 3 over 10 minus 30 times 7k over 15 equal to 30 times 2 over 3. This is using 30 to multiply all the terms. But if we want to use the distributive property, that means we just say use 30 to multiply both sides. Use 30 to multiply both sides of the equation. That is the left-hand side and the right-hand side. This is kind of a vocabulary. This one means use 30 to multiply all terms. This is use 30 to multiply all terms of the equation. All terms of the equation. That is the first term, the second term, and the third term. In this case, the first term is 3 out of 10. The second term is negative 7k over 15. And the third term is 2 over 3. Using 30 to multiply all terms. All terms. Or you can say both sides. Both sides Both sides means we use 30 here times the left hand side, 3 over 10 minus 7k over 15 equal to, this is using 30 to multiply the left hand side, and then this one is using 30 to multiply the right hand side. Still means the same. I mean, it still will give you the same answer. Now when you do this now, you can now do what? Apply the distributive property on the left hand side. Distributive property on the left hand side. Okay? And when we do that, we now have this. When we do that, we now have this. When we apply the distributive property on the left hand side, we now have this 30 times 3 over 10 minus 30 times 7 over 15 times k equal to 30 times 2 over 3. So, just to explain the vocabulary is important. So when you do that, you now have this, and let's continue from here. So, when you have this now, we now multiply, we go ahead and multiply. 10 into 10 is 1, 10 into 30 is 3, 3 times 3 is 9, minus 15 into 15 is 1, 15 into 30 is 2, 2 times 7k is 14k, equal to 3 into 3 is 1, 3 into 30 is 10. 10 times 2 is 20. Then, what do we do here? If we solve the equation, we can subtract 9 from both sides, right? So this goes, and you have negative 14k equal to 20 minus 9 is what? 11. And then you now divide both sides by negative 14. So that gives us that k is equal to negative 11 over 14. Our k becomes negative 11 over 14. Alright. The next thing we do is to do what? To check our work, to see whether we are right or wrong. So, we just write check here. And I kind of hope to use some space here. Let's see. Okay, so we write our check. We write the main equation, 3 over 10 minus 7k over 15 equal to 2 over 3. So we write our left-hand side and then our right-hand side. Our left-hand side is what? 3 over 10 minus 7k over 15, and our right-hand side is 2 over 3. Now, let's do this. I don't have a lot of space, so I will probably just do it here. But you understand what I'm saying? Yeah. So, we now substitute for k. K, we got k as negative 11 over 14. Let us see whether we are right or wrong. So, we substitute it here, assuming we have 3 over 10 minus 7k over 15. So this will mean what? 3 over 10 minus 7 over 15 times, because this means times k. I hope you know that's what it means. So this will be 3 over 10 minus 7 over 15 times negative 11 over 14. So this will be what? 3 over 10 minus times negative, or negative times negative, or you say minus times minus. It means the same thing. It's plus. Then 7 times 11 is what? 7 is 7 over. Now, before we do this, actually, you know, we can simplify it. We can kind of simplify it first before we do this before we do that. This will be 3 over 10, okay, minus. Now, 7 into 7 is what? 1. 7 into 14 is what? 2. So, you can now say minus 1 times minus 1 over 15 times minus 11 over 2. That gives you a plus. Minus times minus is plus. 1 times 11 is 11 over 15 times 2 is what? 30. Yeah. Be careful as you're doing this. Now, there is no difference between minus and negative and subtract. They mean the same thing. Minus, negative, subtract, it means the same thing. And when you multiply two negatives or when you multiply two minus signs, it gives you a positive. Okay? Now, we can go ahead. This is now 3 over 10 plus 11 over 30. When we add, we've done addition of unlike fractions. So, the LCD of 10 and 30 is 30. So, this is good. When we convert this to 30, equivalent fraction will be 10 times 3 is 30, 3 times 3 is 9. So this will be 9 out of 30 plus 11 out of 30. These are now like fractions. And this will give you what? 20 out of 30, because 9 plus 11 is 20. And if you simplify it, it gives you 2 out of 3. So you have 2 over 3 on the left, 2 over 3 on the right. We're good. Okay, let's go ahead and finish the rest, 3, 4, and 5. Now, for question 3, we now come to decimal. So we gotta change this now. To solve equations with rational numbers by clearing decimals, now this is no longer with LCD, like fractions with it. This one is now decimals. By clearing decimals, the first thing we want to do first is we want to know the greatest number of decimal places. That's what we want to know. Okay? Find the greatest number of decimal places, or places of decimal. That's the first thing you want to know. Okay? Now, and I can call this DP. DP. Decimal places. Then number 2, okay? You now find 10 ways to power this DP. Okay? Find 10 raised to power this DP. Now, but this DP is decimal places, but it should be the greatest number of decimal places. Then you raise it, you now raise as an exponent with the base as 10. 10 raised to power this DP. And then whatever it gives you, you now multiply both sides of the equation by 10 raised to power this DP, the greatest number of decimal places. You now multiply it by 10. And then this now gives you, you now have an equation involving integers. Okay? Then you solve the equation. And then you check your solution. So that's the way we do this. We want to solve equations with rational numbers by clearing decimals. This is what we do. Okay, can we go ahead now and erase out of the fractions so we kind of have more space here? Okay, so if we look at number 3, if you look at, let's start from the left hand side, 2.5, how many decimal places? 1 decimal place. Now, decimal places are just the numbers you find after the decimal point. This is a decimal point, so how many numbers do you have here? 1. This is 1 decimal place, this is 1 decimal place, and this is 1 decimal place that has the variable that we want to find. Okay, so the greatest number of, in this question 3, the greatest number of decimal place, the greatest decimal place is what? 1. Okay, remember we have to do greatest decimal place. Is 1. This has to be greatest decimal place. Take note of that. Not just decimal place, but greatest decimal place. I can put this as GDP. How about I put in GDP? GDP. Greatest decimal place. Okay? GDP, 1. So you now find 10 to the power 1. 10 exponent 1. 10 raised to the power 1 is 10. Right? So you now use 10 to multiply both sides of the equation. So this will be 10 times 2.5 equal to 10 times 5.2 plus 0.4n. This is what you have. Okay? This is what you have. And I'm going to come down here from here. I'm coming down here, over here, from here. 10 times 2.5 is what? 25. Equal to, you can apply the distributive property. You can apply the distributive property on the right hand side. This will be 10 times 5.2 plus 10 times 0.4n. Okay? So this will now be 25 equal to 10 times 5.2 is what? 52 plus 10 times 0.4n is 4n. Okay? Now what do we do next? I think I will now use this space. What do we do next from here? We want to make sure we rearrange. Why do we want to rearrange? Because our variable is on the right hand side. Remember, I've explained this in previous videos, why you need to rearrange. Rearrange means make your left hand side to be your right hand side and your right hand side to be your left hand side. Okay? We've explained this before. Like you have, if you have 2 plus 3 to give you 5, 5 is equal to 2 plus 3. It's the same thing. Now, because our variable is on the right, we want to rearrange so that our variable can be on the left. Okay, and I explained the reason. So 52 plus 25 is equal to 52 plus 4n. You rearrange, okay? You rearrange, make your right hand side to be left hand side, and then left hand side to be right hand side. So what we have now is 52 plus 4m equal to 25. Then you subtract 52 from both sides, minus 52, minus 52. And you have that 4m is what? You have 25, you owe 52. So you still be owing 12 minus 5 is 7, and 4 minus 2 is 2. Right? So m will be what now? What will be m? You now divide both sides by 4. So m will be, when we do this division sign, 4 divide, m is a negative answer. Now let's divide 27 by 4. 4 times 6 is 24. right? 7 is 28. So now this will be 27 minus 24 is 3. Then you put your decimal point, you add 0. 4 into 30 is 7. 7 times 4 is 28. 30 minus 28 is 2. Then add 0. 5, 20. And that's it. So negative 6.75 is the answer. Now let me explain something to you. If you're given an equation with decimal, leave your answer as decimal if possible. If you're given an equation with fraction, leave your answer as fraction. Okay? Unless you're told otherwise, or unless it comes out to be a whole number or an integer. If it comes out to be a whole number or if it comes out to be an integer, that's fine. Yeah, you just work it, normally. Otherwise, you wouldn't say to come and convert this to fraction or to leave it as an improper fraction or as a mixed number. Now, unless you're told otherwise, leave it as decimal because you saw it in decimal form. All right? Now, the next thing we have to do is to do what? To check our work to see whether we are right or wrong. So let's check. And when we check from the main equation. So it looks like I'm going to use this on this. So we write check. We write the main equation 2.5 equal to 5.2 plus 0.4m. Then we write our left-hand side and our right-hand side. Our left-hand side is what? 2.5. And our right-hand side is what? 5.2 plus 0.4 times m. So we will focus on our right-hand side. We'll focus on it. So we now have 5.2 plus 0.4. Then we substitute negative 6.75 for m. Okay, you still remember how to multiply decimals that you did in lower grade levels? We're going to do that now. Now this is 5.2. Okay, positive times negative is negative. Now let's do 0.4 times 6.75. How would you do that? How would you do 0.4 times 6.75? So we have 0.4 times 6.75. Let's just put it as integers first. 675 times 4. 4 times 5, 20. Carry 2. 4 times 7, 28 plus 2, 30. Carry 3. 4 times 6, 24. Plus 3 is 27. Right? And we have 2 decimal here. 2 decimal places plus 1 decimal places is 3. 1, 2, 3. 2.7. Okay? So this will give us 5.2 minus 2.7. Right? And then you now do 5.2 minus 2.7. 12 minus 7 is 5. 4 minus 2 is 2. 2.5. So this gives you 2.5. 2.5 on your right. 2.5 on your left. Okay. That's great, right? All right. Next one. Question 4. Negative 1.2p plus 1.25 equal to 0.77. All right. How many decimal places is here? 1. Okay, don't count p. No, p is a variable. Okay. How many decimal places here? 2. 2. So the GDP, greatest decimal place is what? 2. Now 10 raised to power 2. You now do 10 raised to power 2 is what? 10 times 10, which is 100. So you now use 100 to multiply both sides. 100 times negative 1.2p plus 1.25, all in parentheses here, equal to 100 times 0.77. So we now use distributive property, right? 100 times negative 1.2p plus 100 times 1.25 equal to 100 times 0.77. 100 times negative 1.2p is what? Now, remember you move 2 zeros, right? 1, 2. So this will be negative 120p. Okay? So that will be negative 120p. You move zeros forward twice. 1, 0, 1, 0. So negative 120p. Plus, you move it here, 1, 2, 125 equal to, move it here, 77. You have achieved your aim of making it equation with integers. So you look at the essence now. We might be given equations with fractions or equations with integers, okay? In other words, equations with rational numbers. Your aim is to just make it to be equations that have only integers, and then you solve it. So that is the skill that, that's the concept where we want you to understand in this lesson. So what do? Now you subtract 125 from both sides, right? And of course, this will go, this is negative 120p equal to, this will be negative 15 minus 7 is what? 8. 11 minus 7 is what? 4. Right? Negative 48. Right? Then you now divide both sides by what? You divide both sides by what? Negative 120. So that you can isolate p. So you can isolate p. Right? So when we do that, let's find what our p is. And then we can let's find what our p is, and then we can check our work. So if we continue from here, we see that our negative 120 will divide negative 120. So our p will be negative 48 over negative 120. Of course, you divide by what now? 12. This will be negative 4 over negative 10. And of course, these two negatives, you can just leave it. So you have 4 over 10. Negative divided by negative is positive. And then you divide by 2. This will give you 2 out of 5. So our p is 2 out of 5. Another way you can do it is divided by 24. Because 24 is the greatest common factor. And once you do it, you get the answer right away. Okay? Okay, so now the next thing we have to do now is to check our work. Right? So we check. Let's just do this. So when I check, we write check here. We write the main problem. Negative 1.2p plus 1.25 equal to 0.77. Now, yeah, we have to do what here? Since we are given in decimal, we have to leave our answer in decimal. So if you do that, what would it be? 0.4. Okay? Because when you do 5 divided by 2, 5 divide 2 or 2 divided by 5. Let's get the correct terminology. It is 5 divided 2 or 2 divided by 5. So 5 into 2 or 5 divided 2, it won't go. Put 0 point, then put 0 here. That is 4, 0.4. 20, that's 0. So 0.4. Leave your answer as decimal because they gave it to you in decimal. Okay? So our left hand side and then our right hand side. Our left hand side is what? Negative 1.2p plus 1.25. Our right hand side is 0.77. Okay, so we now substitute 0.4 for p on the left hand side. So this will be negative 1.2 times 0.4 then plus 1.25. Okay? 12 times 4 is what? If 12 times 4 is 48. And this is 1, 2. So 1, 2. This is now negative 0.48 plus 1.25. So what will it give? 15 minus 8 is 7. 11 minus 4 is 7. And 0 minus 0 is 0. 0.77. So 0.77 on your left, 0.77 on your right. Okay? And that's the way you do that. Alright, the last but not the least is the real world problem. The last but not the least, real world problem. The perimeter of a rectangle is 90 centimeters. The length is 10 centimeters. What is the width? So let's kind of visualize this rectangle. Assuming we visualize it, the length is 10 centimeters. Of course, 10 centimeters, 10 centimeters. And let W be the width. W. Now, with the formula for the perimeter of a rectangle, when you have a rectangle, right? Okay, it could be this or this, it doesn't matter. Now, assuming you have the length, width, this will be, the perimeter will be what? Length plus width plus length plus width. Perimeter will be length plus width plus width. It is the perimeter means the whole distance round, the entire distance round the rectangle or the shape or the figure. So perimeter will be 2 length plus 2 width. Okay? That's the perimeter. Now in this case, we have that our perimeter is 90 centimeters, right? We have that our length, L, we can use lowercase, it doesn't matter. We have that our length is 10 centimeters, and we now want to find our W, our width. So we find that 90 is equal to 2 times, when you have it from here, you can say that P is equal to 2 length plus width if you factorize it. Okay? We can either use this or we can use this, it doesn't matter. Right? But if we now use this, because we need to distribute, from here, if you distribute, it will be 2 times length plus 2 times width. So when we do this, we have that 90 is equal to 2 times 10 plus 2 times width. Right? 90 is equal to 2 times 10 plus 2 times width. So let's finish it up here. So this means that 90 is equal to 2 times 10 is what? 20 plus what? 2W. Rearrange to make your left to be your right and your right to be your left. So 2W plus 20 is equal to 90. You subtract 20 from both sides, right? You now have that 2 times W, 2 times the width, will be 90 minus 20 is what? 70. And then you divide both sides by 2 to isolate the width. You divide both sides by 2, and your width will be what? 35. 35 what? Centimeter. Make sure you put your unit. It is very important that you put the unit. Very important. And how do you check this actually? Okay, this becomes a 35 centimeter. This becomes 35 centimeter. Add it up. 35 plus 35 is what? 70 plus 10, 80 plus 10, 90, the perimeter. Thank you so much for listening, and you have a great